Hey there, chemistry students. Our next target that we want to talk about in this unit is to be able to describe trends in the properties of the elements. We've talked about the periodic table, and we've talked about how the different properties of the elements are periodic, which means they repeat in a regular kind of pattern. So now let's go ahead and let's talk about what are some of those properties and exactly how do they repeat. So in this video, we're going to talk about 4 properties of the different elements and what their patterns are, what you see in the periodic table. We're going to talk about the atomic radius, the ionization energy, the electron affinity, and the electronegativity. So the first one to talk about is the atomic radius. When you think about atoms of the different elements, they're not all the same size. And that's kind of what atomic radius is getting at. Atomic radius is kind of like the actual physical size of the atom. Just like you might describe how big a circle is by talking about its radius, we can describe how big an atom is by talking about its radius. And all the different elements, their atoms have different radii, they have different sizes. Now there's some definite patterns in the atomic radius of the different elements as you look at them on the periodic table. As you go down a column of elements, what you'll see is the radii, the size of the atoms, gets bigger. So the ones towards the bottom of the periodic table are bigger than the ones towards the top of the periodic table. And as you go down a column, they get bigger and bigger and bigger. And that's kind of easy to see if you think about electron energy levels, because as you get further down the column, they're going to have more energy levels and thus be bigger atoms, right? As you move across a row on the periodic table, you'll find that the atoms get smaller. So the ones all the way towards the left side of the table are bigger than the ones towards the right side of the table. And so as you move along, the atoms get smaller and smaller and smaller. And at first this might not make sense, because as you go across, the atoms get more protons and more electrons, and so you think they might get bigger. But if you think about it, they all have the same number of energy levels across the row, but they're getting more and more protons as you move across. And with more and more protons, those protons pull on the electrons harder and harder because there's more and more of them. And so what happens is the electrons might stay a little bit closer to the nucleus as you move across the row. So as you move across the row, the atoms actually get smaller. They have a smaller atomic radius. So the biggest atoms on the periodic table are going to be towards the bottom and left, around about where you find francium. Okay? The smallest atoms are going to be towards the top and right, towards where you find helium. So helium is going to be the smallest one on the periodic table, and francium up there is going to be the largest one. The next one to talk about is called ionization energy. And it sounds kind of like a big scary vocabulary word, but I tell you what, it's really not that difficult a concept. Ionization is the process of removing an electron from an atom, forming what's called an ion. An ion is really just an atom that's either got extra electrons or it has lost electrons. So ionization energy is it's just how much energy does it take to steal an electron away from an atom. And each different kind of atom, each different element is going to have a different amount of energy to steal away an electron from it. And that amount of energy we call its ionization energy. And there's a very clear pattern in ionization energy on the periodic table. And it's actually the exact opposite pattern from the atomic radius. So as you go down the column on the periodic table, the amount of ionization energy decreases. So the ones towards the top of the table, it takes the most energy to steal away an electron, and the ones towards the bottom, it takes the least energy to steal away the electron. If you think about it, it kind of makes sense to me, because those ones towards the bottom are big atoms. Their electrons sit further away from the nucleus, and so it's going to be easier to steal one away. The ones towards the top of the table are tiny, compact atoms, right? And so if you want to steal its electron away, well, that electron is going to be close to the nucleus, so you're fighting the nucleus to steal the electron away much more. So think about the ones towards the top are holding their electrons close, they're hard to steal away, so it's going to take a lot of energy. So they have a high they have a high ionization energy. The one towards the bottom, they're not so much concerned with holding onto their electrons, so it's much easier to take them. They have a lower ionization energy. As you move across a row, the ionization energy will increases. So the ones towards the left have the lowest ionization energy, and the ones towards the right have the highest ionization energy. So if you look at your periodic table, the ones with the lowest ionization energies should be towards the bottom left corner, like right around francium. We'll have one of the lowest ionization energies, and the ones with the highest ionization energies will be towards the top right. So like the ones around helium over there have the highest ionization energies. The third one to talk about here, just kind of briefly, is what's called electron affinity. Just like with ionization energy, you can strip electrons off of an atom. You can also get atoms to accept extra electrons. And the atom's tendency to accept extra electrons we call electron affinity. Think about it, if you have an affinity for something, that means you kind of like it, that means you're good at it, right? So electron affinity, atoms with a high electron affinity would, be good at picking up extra electrons. There is a pattern in electron affinity. It's not the most clear-cut pattern across the periodic table. The ones towards the right side of the table will have a high electron affinity. They're going to want to accept extra electrons. But the highest ones are actually going to be the halogens in column 17, because when you go to the next column, column 18, the noble gases, they actually do not really easily accept extra electrons. So as you move across the table, electron affinity kind of generally goes up, but then when you get to the halogens, that's the highest point. And then the next column, the noble gases have very low electron affinities. So there is a pattern here. It's not the clearest cut pattern, but there definitely is a pattern with the electron affinity. That kind of break between the halogens and the noble gases when it comes to electron affinity is not that tough to understand if you think about their electron configurations. The noble gases, if you recall, have their very last orbitals completely full. So, they already have all of their orbitals full. And if you think about the halogens are just one electron shy of having their last orbital completely full. And one of the things we're going to learn more about when we talk about chemical bonding is that atoms are going to try to have those outermost orbitals filled. They want those orbitals filled. So those halogens that are just one electron shy of having that outer orbital filled are the ones that are most easily going to accept extra electrons and have the highest electron affinity. And then the next column over, the noble gases, you can see why there's a break here, those ones already have that orbital filled. So they don't want to accept any extra electrons, which is why the electron affinity shoots back down right there. So, you can fairly easily see that by looking at the electron configurations. The last one to talk about here is what's called electronegativity, and this is going to be an important one going forward in class. In our next unit after this, we're going to use the electronegativity to predict what kind of bonds atoms will form with each other. So electronegativity is something that we're going to see again. Electronegativity is kind of a measurement of how strongly an atom attracts electrons, either its own electrons or electrons from other atoms. Some atoms will, grab onto electrons and hold them really tightly. Some will, kind of gently hold on to it, and their electrons can be easily taken away. So electronegativity is kind of how strongly do they attract electrons. And there's a very clear pattern in electronegativity across the periodic table. As you go down a column, the electronegativity decreases. So it's highest towards the top, and it's lowest towards the bottom. As you go across the periodic table from left to right, the electronegativity increases. So it'll be highest over towards the right and lowest over towards the left, except for the noble gases, which have very low electronegativities. So electronegativity is highest in the halogens, and then it drops off for the noble gases, and then it's low on the other side of the table. So as you go from the one side to the other, it increases, except for the noble gases. So the highest electronegativities are going to be right around fluorine on the periodic table. But fluorine has the highest electronegativity. Fluorine, oxygen, nitrogen, right there, those are the highest electronegativities. And then the lowest would be down towards the other corner of the table, down by francium. This is the same pattern that you see with the ionization energy. So ionization energy and electronegativity, if you look at their definitions, they sound kind of very similar, right? And in fact, you see the same pattern there in the periodic table. So electronegativity. So one more thing I want to point out here is if you go to ptable.com, you can actually look up any of these properties for any of one of the elements you want to. You just find your element that you're interested in, come over to this side table here, and then you see right here is the electronegativity. Down here you find the electron affinity. There's the ionization energy, and right there's the atomic radius. And in addition, there's all of these other properties that we haven't discussed. So you can find all the numbers for these things right there on ptable.com. Okay, so there was some of the trends that you see in the periodic table for those 4 different properties. We talked about atomic radius, ionization energy, electron affinity, and electronegativity. And I'm going to tell you what, I will not ask you very many questions at all about electron affinity. The pattern there is kind of rough. So it's really only the other 3 that are really important for us to kind of know for class. The atomic radius, the ionization energy, and the electronegativity. And you can take those and you can kind of, draw yourself a periodic table and maybe put some arrows on the periodic table to demonstrate the trends. And then you can, take a look at that and you can see what the trends are. And in fact, I think I have it for you right here. And I'll give you, this might be important for you to know. Okay. Hopefully that gets us a step closer to being able to describe the properties, the trends and the properties of the different elements.